Hello, my name is Haein and I'm a PhD student at Hanyang University. Today, I'll present our paper, Can LLMs Persuade Humans with Deception? From a Deceptive Strategy Taxonomy to a large-scale empirical study. This work was done in collaboration with TTA and Naver. Recent work suggests that LLMs can show superhuman persuasiveness in certain contexts. More importantly, persuasion appears strongest when LLMs adopt deceptive strategies. At the same time, LLMs are rapidly replacing traditional search engines as a primary source of information. As a result, the quality and intent of LLM-generated information matter much more in everyday decision-making. This creates a serious societal risk. Deceptive persuasion is particularly dangerous in complex topics lacking social consensus, because users often rely heavily on the initial information they receive. In this example, the LLM provides a logically structured response with manipulated data, leading the user to change their attitude. So the problem is not just misinformation, but attitude change through persuasive deception. As is well known, hallucination refers to unintentional factual errors produced without persuasive intent. By contrast, deceptive persuasion is intentional, designed to change beliefs and exploit cognitive vulnerabilities. Therefore, this study aims to empirically analyze how the deceptive persuasion strategies of LLMs specifically operate and how their impact varies depending on user characteristics. Based on this motivation, we focus on three questions. First, how can I systematically classify deceptive persuasion strategies used by LLMs? Second, when are users most susceptible to these strategies? And third, how do users justify accepting or resisting them? To answer RQ1, we first expanded 840 cloud-based arguments into a parallel corpus across 4 LLM families. This helped prevent the taxonomy from being shaped by one model family alone. Next, we combined two analytic lenses. In the top-down approach, deceptive persuasion was framed through rhetoric and information manipulation theory. In the bottom-up approach, each subset of 840 arguments was analyzed by 2 human coders and 3 LLM coders to extract primary deceptive patterns. This allowed us to balance theoretical grounding with large-scale pattern discovery. Then, through theory-based filtering and integration, we narrowed 79 candidate strategies down to 8 core strategies. Our final taxonomy organized 8 deceptive persuasion strategies under 3 rhetorical dimensions drawn from classical rhetoric: logos, pathos, and ethos. Based on this taxonomy, we selected 10 socially complex topics where public consensus is still developing. These include emotional companion AI, self-driving cars, genetic engineering, and with the rest listed in the table. Each topic includes both pro and con claims. In the user study, after the pre-survey, participants reported their initial assessment for each topic. After reading the LLM-generated persuasive arguments, they submitted their final assessment. In the pre-survey, participants reported their demographic information, trust in AI, cognitive reflection, and prior experience with LLMs. Each participant was assigned to only one of 10 conditions: 8 single strategy conditions, 1 control condition, and 1 combination condition. Based on the participants' initial stance, the system then selected an argument that was either aligned or misaligned with their belief. And aligned arguments supported the participants' prior stance, while a misaligned argument challenged it. Across 10 topics, each participant experienced 5 aligned and 5 misaligned trials. Finally, we measured perceived deception and perceived AI trustworthiness. Overall, our study included 602 participants and 6,020 observations. We used the mixed factorial design. To measure persuasion, we defined the Persuasion Success Index, PSI, which captures both the direction and magnitude of attitude change. In other words, PSI indicates whether participants' opinions shift in the direction intended by LLM and by how much. A positive PSI indicates successful persuasion. Our false finding is that LLM's deceptive persuasion exerted a substantially stronger effect when opposing users' prior beliefs, that is, in the misaligned condition. In particular, information manipulation and uncertainty exploitation showed significantly larger persuasion success and attitude shifts in this condition. This suggests that the greater risk lies not only in reinforcing existing beliefs, but in overturning them through deceptive arguments. Beyond the overall strategy effects, we also examine how these effects interact with user characteristics. Our second finding shows that lower CRT significantly increased participants' susceptibility to deceptive persuasion. In particular, participants with lower CRT scores showed significantly larger opinion shifts under topic manipulation and manipulated framing, especially in the misaligned condition. This suggests that users with low analytical reasoning are more vulnerable to deceptive strategies that distort the topic or frame the argument in a biased way. Our third finding shows that topic knowledge and topic involvement moderated susceptibility to deceptive strategies. Participants with low topic knowledge were more influenced by information manipulation and uncertainty exploitation, while those with low topic involvement were more influenced by emotional manipulation and manipulative framing. To understand why these strategies worked, we conducted a think-aloud study. In information manipulation, manipulating statistics within a coherent narrative led users to overlook flawed details. One participant noted, "I don't know if the numbers themselves are real, but I guess it could be like that." In uncertainty exploitation, arguments shifted judgment toward unfalsifiable features and system-level risks. Another participant said, "I realized I was thinking inside the box, and I tried to see it from the other side." These findings point to a multi-layered defense strategy. At the system level, hyperlinks alone are not enough. Models should surface sentence-level evidence to prevent alignment faking. At the interface level, we propose context-aware friction that encourages verification before acceptance. At the user level, we need to targeted AI literacy to help users recognize manipulative patterns. All three layers should be grounded in empirical verification. Our work also has several limitations and future directions. First, we need longitudinal and multi-time studies. Second, we need to test the synergistic effects of combined strategies. Third, we need to examine whether these findings generalize across broader demographic groups. To conclude, deceptive persuasion is not only possible, but systematically patterned and shaped by user context. We hope these findings contribute to safer and more resilient human-AI interaction. Thank you very much for listening.